Okay, this is the Unit 4 review for Algebra 2. I'm not going to go through as many questions as I normally do in one of these videos, but I do want to get you started on a couple of them and look at the application section. So this review packet will be worth a small summative grade rather than a formative. So it is going to be really important that you guys make sure you get this Unit 4 review sheet turned into me, whether that is a picture that you send to me through email, or if you show me on Google, that might be good enough, but I am going to be actually looking at your answers a little bit more thoroughly for this one. If you want, you can just email me or tell your advisor to call me, and I'll come into your room and check over your assignment in person too. So super important that you get this done. All right. So the first couple questions, we are solving these systems by substitution. So we want to solve for one variable and then plug it into the other equation. So you're looking for a coefficient of 1. That would be the easiest way. And I see that right here, we've got 1y. So this would be the easiest one to isolate. All we would have to do is add 3x on both sides. So you have y is equal to 3x minus 2. And then what we're going to do is we're going to take this out. If y is equal to 3x minus 2, we're going to just plug it back in for this y. So we're going to take this and do negative 6x plus 2 times 3x minus 2 is equal to negative 4. And now you're dealing with the same variable. You can isolate it and solve. So once you do that, remember you have to, actually I'm going to do this one for you because this one's a little bit unique. So we're going to multiply this out. 2 times 3x is 6x. 2 times negative 2 is negative 4. Update the problem, drop everything else down. And what I'm left with is, well, we need to combine like terms. We have negative 6x plus 6x. Well, these will cancel out, right? Okay, so if the variables cancel out, you got to see what you're left with. And what I'm left with is this identical statement, right? This is a true statement. So negative 4 is equal to negative 4. So basically what that means is that there is infinitely many solutions for x, okay? If you get something that does not equal each other, like, negative 4 is equal to any other number, well, then it's going to be no solution, okay? So that one's a little bit unique. You're going to have another special problem like that later on, but I won't tell you which one. So negative 2, or sorry, for problem number 2, you're going to do the same thing. X is already solved for you, so you just want to take the first equation, plug it into the second. Elimination for 3 and 4. Right now we have nothing set up to cancel, so I'm going to have to do something here. And I think the easiest thing would be to just take this top equation and multiply everything by negative 5. So if I do that, negative 5 times positive 2x is negative 10x. And that is why I'm going to do this, right? Because when I add the two equations together, 10x minus 10x, those will cancel out. Negative 5 times positive 4y is negative 20y. And negative 5 times 23 is negative 115. So now go ahead, add these together. These will cancel out. And I'm going to leave the rest for you. Remember, once you solve for y, you still have to go back and take whatever y value that is and plug it back into one of the original equations. All right. 5 and 6, you can choose whatever method you want. It doesn't matter. You can pick elimination or substitution. It's up to you. 7 and 8, we are solving the systems by graphing. So we're looking at where these linear equations intersect. So you're going to want to plot these out. You could use x and y intercepts, or you can isolate y. You could put it in slope-intercept form. If you're going to do that, the top equation, right, we would subtract 2x on both sides and then divide by 3. So you'd be left with, let's see, negative 2/3 x plus, minus 4. That sounds about right. and then the bottom equation, you're going to subtract x, and then this is a negative 1y, so we're going to have to divide everything by negative 1, so you should be left with y is equal to x plus 1. Another way to think about that is if you move this one over here, the y over there to the right side, it's going to be positive. And then if you move the constant over to the other side, that would be positive. So that's a little bit of a faster way to get the same answer. But either way, plot those out, see where they intersect. Intersection is the solution. Number 8 you can do on your own. Let's see what else we have. Whoops, where am I going? Okay. And then we've got some, so just 9 to 10 more solving systems by graphing. So put them in slope-intercept form, find the intersection. 11 and 12, we have systems of inequalities. These are pretty basic examples, and there's not very many of them, so I'm not going to do any for you. Just remember, guys, if you are struggling with this on the Google Doc for this week, I am going to include all of my lesson tutorials for the previous week. So if you are struggling with one of these concepts, go back, rewatch the videos, and that should help you out. All right, so let's move on over to the application section. 14 still just a system of inequality problem. 15, you're just going to look to see if this point, so once you do 14, look at this point, see if it is in the shaded section or not, or if it's on the solid or dashed line. You should know what that all means, but do 14 before you do 15. All right, then the application section. So let's see, Mr. Bruss loves creating sculpture candles. In fact, he's going to the store to buy new candles for his new sculpture candle set. Okay, so small candles cost $4, large candles cost $5. He needs to buy at least 20 candles, and he cannot spend more than 200. So I'm going to kind of start this out, but I want you guys to finish it. So we want to write an inequality for both of these. So Mr. Bruss wants to buy at least 20 candles. So we're just going to say x plus y is going to be greater than or equal to 20, okay, because he wants to spend at least $20, okay, or sorry, at least 20 candles. He wants to buy at least 20 candles, and then he cannot spend more than 200. So then now we're going to be actually looking at the costs here, which is 5 and 4. So we're going to say 4x plus 5y. Oops. When we add those together, this cannot exceed, so it has to be less than or equal to 200. Okay, so there's your two inequalities. You definitely need to still solve for y on both of them. And then I want you guys to graph these out on this graph here. And then C and D, name a point that is a solution and a point that's not in the solution. So basically a point that's in the shaded area and a point that's not, okay? So I'm very interested to see how you guys do on that one. So good luck on this. If you do need help with it, come see me on a Google Meet or ask your advisor to call me down to your classroom. All right, thanks.